Question in a technical coding interview. And the question before us says match two sorted lists, sorted linked list, and return it as a new sorted list. The new list should be made by splicing together the nodes of the first two lists. So we have 1, 2, 4, then 1, 2, 3, 1, 3, 4, then we have to have 1, 1, 2, 3, 4, 4. So how do we go about this problem? Let's go the usual way, the umpire method. So the U, that is, we try to understand the problem. So we're dealing here with linked lists, and we have to return each of the linked lists is sorted, and we have to return a new linked list that is sorted. And they said the new list should be made by splicing together. What does that mean? The new lists should be made by splicing together the nodes of the first two lists. Anyway, let's go to the next stage, which is the match. So we try to match with the existing algorithm, which we know of match sort. And the way match sort works is we have two sorted lists, and we start comparing from one to another. Okay. The next phase is the plan phase, where we discuss how do we want to execute the code. So what comes to mind is we can create a dummy list, a dummy linked list, and use the dummy linked list to return the dummy linked list. So as we iterate through, we keep adding to the dummy linked list. It's not feasible how we can try to do it without creating a new linked list. It's not feasible. Okay. So the next is the implementation stage. And the implementation stage, now we try to implement the code. So this is where we are. Then we'll come back to the review and the evaluate stage. So let's see how we can implement this in code. All right. So we have this. Let's say we have we say L3 equals to add and equals to the dummy linked list. So let's say list node of -9. So let's see what we can do. So we can be that while there is L1 and there is L2, if L1 dot val is less than L2 dot val, all right, we will add that. So we will say our add dot next equals to the L1, and we will move L1 forward, which is L1 dot next. We're still going to look at what we're trying to implement after we've written the code. Else we say our head dot next is equals to L2, and then we'll move our L2 forward. So once we're done with that, if there's still something in L1, we will say that our head dot next equals to L1. But here we need to also move our head up, which is head equals to head dot next. And if there's something left in L2, we do the same, which is we say our head dot next will be equals to L2. So that is our taught code. But let's now see how our code works with example. So this is our code, and let's copy example and see how it does works. So this is an example which we'll walk through. So let's see how this works in here. Okay, this is visible enough. So let's see if we can move on. I need to recopy this. Let's paste that. It's not pasting where we wanted. Okay. So let's see now. We have two linked lists. So I'm going to rewrite that. So the first linked list is this is 1 goes to 2 goes to 4. There's something we forgot in our code that I believe we're supposed to return. After this, we're supposed to return the L3 dot next. That should be our final return. So we can recopy this. So we need to have that return. So we can delete this and recopy that. So let's copy this to move it here so we can see it very well. Okay. So we have our input. So I'm rewriting that the first linked list is 1 goes to 2 and then it goes to 4. Then we have 1 goes to 3 and it goes to 4. So let's see what we can do. Why L1 and L2? So the first thing is if this is our L1, this is L1, and this is L2. So why L1 and L2? If L1 dot val, so this is where the L1 starts from. So our L1 is starting from here, which is 1, is less than L2 dot val. Our L2 dot val is also 1. Is it less? No. So what we do is we go to head.next to be equals to L2. So this becomes 1. So this point to 1. Alright. I think I should use a different color so that this will be easy. So this is 1. This is 1. This is this point to 1. So this is 1, this is 1, and this starts from 1. So we are here. This is our L1 and L2. Now we go back. We move our head.next to prepare for the next entry. So the next is waiting here. Then we have moved our L2.next. So our L2.next, our L2.next has now moved. So this has moved here. So let's just delete those arrows. That will not make it big. No. Good. So that is where our L2 is now. The next thing we do is we say our L1 1, is it less than our L2 dot val, and our L2 dot val is now 3. So is it less than 3? Yes. So we say our head.next will be L1. So this becomes 1 again. And we advance our L1. So our L1 is advanced, moves here. And we also, at the end of the day, we advance our head, which gives us a new arrow for the next. So it moves so that it prepares for the next value. Yeah. Good. So next is our L1 is 2 and our L2 is 3. So we check if 2 is less than 3, yes. Then our head.next become L1, which is 2, and we advance our L1. So our L1 is advanced. So this is our L1 is advanced here. So the next thing, then So we've added our 2. So 2 is less than 3. Then we advance our L1 and we've added 2 there. Then we prepare the next arrow for our head.next. So our head.next has a new arrow waiting for it. Okay. Then the next thing is we compare our L1.val, which is now 4. So this is now 4. This is 4. We check if 4 is less than 3. No. So we advance our head.next become the L2. What is L2? 3. So this becomes 3. We also advance our next at the end of the day. Then our L2.next moves. So our L2 will move to this place. Then our L1.val is still 4, but our L2.val has changed to 4. So this becomes 4. So is 4 less than 4? No. So we advance our L2.next to L2, it becomes 4. And our L2 becomes none, because our L2 becomes none. Immediately we advance, this gets to the end of the linked list, that is none. So since our L2 is now none, we only have element left in our L1, and the only thing we do with the element left in our L1 is we just add it. So by the time we get to YL1, L.next will just be L1. So this will just give us L1, which is 4. So this will just give us 4. So the next will just be 4, and that's the end. So at the end of the day, we just return this L3. The next of it will be this. So let's now go and submit our code based on what we have done. Alright. So let's see whether our code runs. Oh, there was an error here. We're actually supposed to advance our L1 and our L2. That's a technical error here. We're also supposed to advance our L2 so that it will reach the end. Right. So that it will terminate. Or if you don't want to advance that, we can just say, we can just use an if here instead of while. I think if is even the appropriate thing, the way we're going. If L1, we just use that. If will be the right one to use. If L2, so that we don't need to advance. So this should give us what we need. Yeah, so there is the appropriate way, because we need to be doing this again if we use the while loop. We have to be doing it one after the other. Okay, let's submit our code now and see what it gives us. Yeah, that's accepted. So that is the only fix we did here. Is instead of using the while, if we had to use the while loop, then we'll need to do this again inside here, and we'll need to do this inside here, and we also need to do this. But since we just want to join the list, we can just see if something remains, just make the next of it to be this. If something remains, then just make the next. So this is easier and cheaper way of doing it. Great. So what is the evaluation? The runtime complexity is big O of n. So let's go to our review. So the runtime complexity, don't forget we amended this to if. We cancel this, we cancel this, and we change this to if, and we change this to if. So what is our runtime complexity? The runtime complexity, we're going to L1 and L2 at the same time, so it will be big O of whichever is bigger out of the two, whichever is smaller, sorry. So big O of the smaller ones. So it will be big O of L1, big O of the length of L1 if L1 is less than, if the length of L1 is less than L2. Otherwise, it will be big O of L2. So that's the time complexity there, because we are going through that. What is our space complexity? Our space complexity is big O of L1, the length of L1, if we are using L1 and L2 for length. So this would be our space complexity for L3, because we are storing all the elements. Alright, that's it. Thank you so much for listening, and I hope you have benefited from this. Do give us a thumb up and please subscribe. Thank you, and see you in the next one.